today we are going to discuss polynomial functions. So what is a polynomial? A polynomial function of degree n is a function of this form. P of x is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus and so on up to a sub 1x plus a sub 0. So for example, x cubed plus 3x plus 2, then that is an example of a polynomial. Now, in this case, the degree of the polynomial is n, okay? Where n is a non-negative integer. So take note, the degree is a non-negative integer. And a sub n minus 1 up to a sub 0, given that it is they are not equal to 0. Okay? So the degree, by the way, is the highest power of the variable. You have to take note that n, since n is the degree, so this is the highest power or the highest exponent of the variable. Okay. Now the numbers a sub 0, a sub 1, a sub 2 up to a sub n, these are what we call the coefficients of the polynomial. So while the number a sub 0 is the constant coefficient or constant term. So the a sub 0 here, this is what we call the constant coefficient. The number a sub n, the coefficient of the highest power. So since a sub 0 up to a sub n, these are the coefficients of the polynomial. A sub 0 is the constant coefficient, and the a sub n, which is the highest or the coefficient of the highest power, is what we call the leading coefficient. And the term having the leading coefficient and the degree is what we call the leading term. Okay, the leading term, this is the leading term, a sub n is the leading coefficient, n is the degree, a sub 0 is the constant coefficient. Okay, so for example, we have here example 3x raised to 5 plus 6x raised to 4 minus 2x cubed plus x squared plus 7x minus 6. This is an example of a polynomial, okay, since it is of the form f of x is equal to a sub n x raised to n plus up to a sub 0. Now in this case, this is what we call the leading term. So the leading term is 3x raised to 5, and 3 is the leading coefficient because it is the coefficient with the highest power. What is the highest power? The highest power is 5. Therefore, the degree of this polynomial function is 5. Okay, so what are the coefficients of this polynomial? The coefficients are 3, 6, negative 2, 1, 7, and negative 6. Okay, now negative 6 in this case is what we call the constant coefficient. Okay, is it clear? Okay, so let's have here another examples. If we are given a constant function, recall, it is a function, okay, it is a function where the range is the set of constant. In this case, p of x is equal to 3, so this is a constant function. Now, what do you think is the degree of this constant function? What do you think is the degree? Is it 1? Is it 0? Is it 2 or what? The degree of this constant function is what? It is, what do you think? It is 0. It is 0 because by the definition of degree, it is a non-negative integer, okay, which is the highest power of the variable. And take note of this, there is no variable, although technically there is a variable here, 3 times x raised to 0. And x raised to 0 or any number raised to 0 is equal to 1. That's why this is 3 times 1, which is 3. Now, what's the degree of qx? What do you think is the degree? The degree is 1. It's the highest power, which is 1. How about this one? It is 2. The degree is 2. How about this? The degree is 3. Now, what is the constant coefficient in this example? Negative 10. What are the coefficients? 2, negative 6, and negative 10. In this case, what are the coefficients? 1, 1. In this case, what is the constant coefficient? It is 0 because there is 0 here. If you add 0, it is still x squared plus x. What is the constant coefficient here? It is negative 7. Okay, so this is how we identify the leading term, leading coefficient, the degree, the coefficients, and the constant coefficient. So we have here summary. If you are given a constant function which is 0, f of x is equal to 0, it has no degree. Then the function is what we call the zero function, and the graph is the x-axis itself. Okay? The graph of f of x is equal to 0 or y is equal to 0. It's the x-axis itself. But if you're given a function, let's say a is equal to, f of x is equal to a sub 0, where a sub 0 is not equal to 0, this is a constant function, then the degree is 0, and the graph of that function is a horizontal line with y is equal to what? With y-intercept is a sub 0. How about of this form? F of x is equal to a sub 1x plus a sub 0, where a sub 1 is not equal to 0 as well as a sub 0. Okay, so the degree of this, since the highest power of the exponent is 1, so we have the degree which is 1, and it is a linear function. Then the graph, you have to take note, it's non-vertical, non-horizontal line with slope a sub 1 and y-intercept a sub 0. Okay, because if this is of the form mx plus b form, where our m is a sub 1 and our b is a sub 0. So the slope is a sub 1 and the y-intercept is a sub 0. How about this one? F of x is equal to a sub 2x squared plus a sub 1x plus a sub 0, where a sub 1 is not equal to 0. Okay? This is an example of a quadratic function. And since the highest power of the variable is 2, therefore the degree is 2. The graph is a parabola, opens up if a sub 2, okay, is greater than 0 or is positive, and the graph opens down if a sub 2 is less than 0 or negative. Okay, so we have here important remarks of the graph of polynomial functions. Now, we have to take note that the graph of polynomial functions are always smooth and continuous. Okay, look at these illustrations. This is not the graph of a polynomial function because it has a break, it has a hole. Okay, it has a jump. This is still not the graph of a polynomial function because it has cusp or it has a corner. It's not smooth. But these two here, these are graphs of polynomial functions. This is smooth and continuous. This is smooth and continuous. Okay? So another type of a polynomial functions, so we consider here the power functions. Now, this one, this is the graph of x cubed, the gray one, and the black one is x raised to 5. So what is your observation? If n is odd, okay, if n is odd, the degree is odd, the graph of the power functions y is equal to x raised to n crosses the axis at the x-intercept. Okay, it crosses the axis at the x-intercept. In this case, what? It crosses the what? It crosses the x is equal to 0. It is the x-intercept. Now, you notice also that this is the graph of x cubed and the graph of x raised to 5. Notice that as n increases, because 3 is lesser than 5, as n increases, the graph of x raised to n, or the graph of power functions, becomes flatter. Okay, x raised to 5 becomes flatter in this part here compared to x raised to 3. Okay, so this is a family of power functions where n is odd. How about if n is even? If n is even, the graph of the power functions y is equal to x raised to n touches the axis at the x-intercept. Okay, it touches the axis at the x-intercept. In this case, the x-intercept is x is equal to 0, right? Then it touches the x-intercept. Now later, you will understand more if we will be having an example, okay, which is not only of the form x raised to n. There is a constant, or there is another um, term that is added to the power functions. Now, as you can see here, if n is even, let's say x squared, n is the exponent is even, um, it is a parabola. Okay? Now, if x raised to 4, what have you noticed? X is raised to 4. The graph becomes closer. This one, the y values becomes closer to the y-axis. By the way, yeah, no. Sorry. The gray one is the x squared. Okay, the graph of x squared. Now, as you can see, the graph of x raised to 4 is flatter in this side compared to the graph of x squared. So as n increases, the graph becomes flatter, closer to the x-axis, but it is this y values here becomes closer to the y-axis as n increases. Okay, so we have f of x is equal to a times x raised to n, where a is any real number, as long as a is not equal to 0 and n is a non-negative integer. So for example, these are power functions here. F of x is equal to 3x, the exponent is 1, and this is a linear function. You expect that we can form a linear function because the highest power is only 1. But g of x is equal to negative 5x squared. This is another example of a power function with leading coefficient, which is negative. So since the leading coefficient is negative, therefore, this is a parabola opening downward. How about h of x is equal to 8x cubed? Okay, the graph of this is looks like x cubed. Okay, it differs only on the coefficient, which is 8. So all we have to do to graph x cubed first, then you multiply each y value to 8 to sketch the graph of 8x cubed. How about t of x? T of x is equal to negative 2x raised to 4. Now, we expect that this graph looks like x squared, x raised to 4, x raised to 6, x raised to 8, as long as n is even, but it is opening downward since the leading coefficient is negative. Okay, so those are the polynomial functions, and the power functions also one of a polynomial functions. So hope you like this video and don't forget to share the learning that you've got from this video. Thank you so much and God bless.